everyone, we're going to prove triangle congruence by side-side-side congruence postulate. So we'll get started. This is mainly a definitional video with some examples. So basically the postulate says side-side-side congruence postulate. If three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. So basically it's all marked here. So these sides are congruent, these two sides are congruent, and these two sides are congruent. So that means the triangles are congruent. Alright, so to do a proof for this one, we know that these segments are congruent, and G is the midpoint. We want to prove that, let's see, FGJ, this triangle is congruent to HGJ, this triangle. Alright, so this is the midpoint. Now, we have our given, and G is the midpoint. So we know that if it's the midpoint, then these two sides are congruent. We also know through the reflexive property, anytime you have like a midpoint type line, you're always going to write that GJ, this line here, is congruent to JG. They're the same line, but that's the reflexive property. So by our congruence theorem, we have all sides equal. That means the triangles are equal. So let's do a little checkpoint. Are these triangles congruent? Well, we have these two sides equal. We have these two sides equal. These two sides are equal. The 8's equal. And then our reflexive property, this is equal. So this is true. Now what happens with this one, we don't have a mark right here. So we can't say that RS is congruent to TV, or we can say that SR is not congruent to WT, or we could say that what they did, RS, is not congruent to this one. So we have these three. These two are congruent. And these two lines are congruent. But we don't have any ticker marks here and here. So that's false. The triangles are not congruent. Now this is what we're going to have to do in class. We want to know if our PQR is congruent to the other triangles. So you can kind of count. This is 3, and this is 3, and QR is 5 if you count, and if you count this side, that is 5, and then use the distance formula for both. You get square root of 34, and that's for this side. So that means they'll be congruent. We did 2 congruents here, so 2 distances. All right. Now if we look at the other triangle, this one, we get the distance from W to V, which is right here, is square root of 10. And it doesn't match square root of 34. So our triangle PQR is only congruent to triangle SRT. So you need to know your distance formula when we're doing these problems, because all 3 sides have to be congruent. All right. So Here's another example. We have the vertices and we graph the triangles. And we know that this is 2. This side is 2. This is 1, 2, 3, 4, 5, 6. Count this side. 1, 2, 3, 4, 5, 6. So basically these two are congruent and these two are congruent. And doing the distance formula, when you do that, you get the distance equals, and you plug in your points, and you get square root of 40 for both of them. So since all sides are congruent, the triangles are congruent by the side-side-side congruence postulate. And finally, we're going to talk about stability. So we're going to explain why the table with the diagonal legs are stable, why the ones without the diagonal legs can collapse. The reason that this table is more stable is because it forms triangles with fixed side lengths. So by the side-side congruence postulates, these triangles cannot change. That means the table is congruent. So cannot change means stable. So just make sure you get this. Cannot change shape, so the table is stable. The table without the diagonal legs is not stable because there's many possible quadrilaterals with the given side lengths. And the same thing with this one. We have congruent sides here. So these triangles are congruent. And by the reflexive property, this is the same. So since it cannot change shape, it is stable. However, this one, the sides aren't congruent. So these sides aren't congruent. We're talking about quadrilaterals versus triangles. And so basically, more stable means triangle. All right. And that's it. Thank you. Have a nice day. Bye-bye.